Off here. So welcome back, everyone. This is our third session on Sysmax Studio, and we're calling it Intermediate Programming today. So some things we're going to be going over is the creation of structures, commonly called UDTs or custom data types. Then we're going to cover something that is directly related to the structure creation, and that is the offset type. So that's a very important aspect of structure creation. Then we are going to go over making our own function blocks. Function blocks are commonly referred to as AOIs or subroutines in a text-based language. Then we'll walk through importing a library and using it in our programs. Then kind of the main event for today will be modifying our list station to increase the capacity. And then the last two items, tag mask manipulation using Excel and bit extraction, are kind of a time pending thing. So we'll see how everything else goes. And we can get rolling here. So Sysmax Studio structures. So a structure is a custom-made data type to suit your application. It might be for a motor. You might have a single data type for an entire plant. But essentially, it allows you to create parent and child tags. So parent.child will be how we access those. We can nest structures within other structures. And it is a really good way to kind of clean up your code. And it's very useful when it comes to the networking side of things. We'll be doing some of that tomorrow. So for our exercise today, our first exercise will be to create a UDT for a VFD control word. So make a structure for controlling a VFD. So in Sysmac, how we make a structure, under our programming, we have a section called data, and then we have a subsection called data types. So I'll get everyone to double click on data types. And we have three options here: structures, union, and enumerated. We're going to focus on structures today. So the first thing we'll do is right click here, and we're going to create a new data type. And we can just call this VFD control underscore NJ. Now I put that NJ there because that's the offset type by default. And we're going to go over that in our next exercise here. So when it comes time to create a member for this structure, we right click and we choose create new member. And then we can assign the data type and the name to it. So I'll put the slideshow back on and you guys can fill in all of the members in your structure. And if anyone's having any issues, you can go ahead and speak up now or type it in chat.
Is there a hotkey to create new members?
I don't believe so. But one thing you can do when you're creating new members is just create one of them, and you can copy and paste it a bunch of times, and it will, especially for the FB in data here. So I'll just delete this one, but it will actually prompt you for the next. So there's FB in data 4.
Yeah,
so
that's way
that
easier.
I had 1, 2, 3, 4. So it, if I wanted to, the next one, it would probably recommend 5. Yeah, so Yeah, I like to just cut and paste them. And ones that are in sequence like this, it will actually kind of intelligently suggest the next item for you.
Hey, yeah, the insert key works. Thank you.
Okay, does anyone need some more time with that? Okay. So now when it comes time to actually use these in our logic, we've created a data type, just like integer is a data type, just like real is a data type. So you guys don't have to do this part, but I'm just going to create a global variable of that data type, just as an example here. And now in the data type, I believe it was VF. Yep, there it is, VFD control NJ. So and now when I use this test structure in my program, all of those members that I created, and again, you guys don't need to do this. This is just an example here, but my test structure dot, and here are all of the members of that UDT, of that structure. So you can make your logic much easier to follow. And we can, and especially when we get into the COM side of things, these are really invaluable. So just going to remove that here. Okay, so that's how we make a structure. And like I said, we can nest a structure within a structure, which can be convenient sometimes too. Now I mentioned offset types earlier, and you may have noticed that column in your structures window. So there are 3 different offset types. There's NJ, CJ, and user, and they all do different things to your data. Now, on the next couple slides, I'll show you essentially what it does to your data, but our next exercise is just going to be to duplicate that structure and make it a user offset. And when it's a user offset, we have to fill in the bit and byte that all of the data sort of maps out to in the structure. So easiest way to do this is just to copy and paste the NJ structure, and I'm just going to call it the VFD control user. We can change the offset type from NJ to user. And as soon as we do that, a whole bunch of fields open up, of offset byte and offset bit. So I'll let you guys look at the PowerPoint and you can fill that in on yours. Okay, so now we're going to do a little exercise to examine exactly what that offset type does to your data. So I'll get everyone to go to their global variables and create a variable of each type, the NJ offset and the user offset. And the global variables is right below data types in your multi-view Explorer. And you can call them whatever you want as long as the data types are the NJ and the user. And I can't zoom in on this part, sorry, it might be a bit small for you. But then the next thing we're going to do is to change the network publish column to input. And this makes it available for Ethernet IP. This is just kind of a little trick to check the size of a variable. It's kind of hard to find otherwise. And now that we've created those variables, I'll get everyone to go up to the top and go to Tools, Ethernet IP Connection Settings. And on the window that pops up, just click on either port, doesn't matter. And then that opens up this tag set window here. So there's a button, it says Registration All. I'll get you to click on Registration All. And it brings up a window that tells you what tags have been made inputs, and it also tells you their sizes. So if you guys remember, this structure we created had 10 members in the structure. So you might be thinking this is going to occupy no more than 16 bits, a word of data. But when we use the NJ user offset, that actually occupied 20 bytes of data, or 10 words. So each member is a minimum of 16 bits when you use the NJ offset. And when we use the user offset, that only occupied 2 bytes, which is what you would expect. That's all the data that you really have there. So looking back at the actual data that we're trying to get here, if we used our NJ structure, the first bit would line up, but the rest of them wouldn't. So it's kind of a rule of thumb, I find, that the user offset type is almost always the way you want to go when you're making a structure. If you were doing Omron PLC to Omron PLC, keep them the same offset type. If you're picking data out of a data map, like we did in our example, go with user offset 9 times out of 10. Now, did that work for everyone? Was everyone able to get into the Ethernet IP connection settings and see their 2 different sizes? I will.
Stu, can you show one more time? After you open the Ethernet IP, what's the setup we need to do? Sorry.
Yeah. Just close out of here. Oops. So we go to Tools, Ethernet IP connection settings. We just pick one of the ports. It doesn't really matter. And then it opens up our tag set window. And we can click on Registration All. And that tells us that's those 2 variables that we created in our global variables. It tells you the data type and it tells you the size.
The size in bit or byte?
In bytes.
In bytes.
Sorry, that's
means
bytes.
20 bytes, it means 2 words.
Yeah, no, 20 bytes would be almost 5 words, I think. Yeah, 5 words would be 20 bytes. No, sorry, 10 words would be 20 bytes.
Yes.
Yeah. And we could just cancel out of there. We were just going in there to check the size. You don't have to register them. If you did register them, it's not a big deal. So we'll close out of there. So those are structures and offset types. Now you use these a lot in communications. that snippet of the variable, or sorry, the VFD control word. When you're communicating with pretty much anything, you're given a data map like that, and you can make a structure for it, and you can use that structure directly for an Ethernet IP data link, or if you were getting some words over Modbus, you can map those directly to that structure as well. There's a few ways to do it. We're going to cover that a bit more in the communications session on Thursday this week. That's offset type. Now we're going to talk a little bit about custom function blocks. So these are commonly called AOIs on some platforms. They're often called subroutines. When we use text-based languages like C, C#, they're commonly called subroutines. But it's essentially a chunk of code that you can recreate, reuse, make as many instances of as you want. And the base object for that code is your function block. And if you make a mistake, you don't have to change your code in 15 different places, for example. You can just change the base of that function block and it will update all of the copies of that function block. Another point, this is a very nice feature. Our function blocks can be online edited. Not entirely, but most of it can be online edited. So you often don't need to shut your plant down if you've got a bunch of function blocks and you had to make a change to them. Now we can combine structures and function blocks to really simplify our programming. We can use structures in our function blocks. We can use structures on our HMI as an IAG. If some of you hung around on the last session, we went over an IAG, how to create one and import it. So we can use the same structure in both places, and we can really expedite our programming that way. And for an exercise, we are going to first make a quick little function block for the pump motor. So we'll have start, stop, reset, and run feedback as our inputs, and our outputs will be run command and the fail to start alarm. So I'll get everyone to go into Sysmac, and we are going to, under programs, we have function blocks at the bottom. I'll get everyone to right click on function blocks and choose add ladder. And then we can rename that motor control. And when we open up motor control, the ladder logic editing environment is the same as when you're looking at your program. But where it differs is up at the top of the screen, there's a drop down called variables. So if we drop down that variables drop down at the top, so this is what's unique to a function block versus the normal programming environment. We have three different types of variables. We have internals, externals, and in-out variables. So internals are variables that don't need to have any interaction with the outside world. If you had an on delay timer, which we'll need for our fail to start alarm, that's going to be an internal because the value of that timer really doesn't matter if the outside world knows about it or not. In-out variables, these are the variables that are going to show up when you actually drop your function block into your logic. They're the inputs and the outputs, as well as in-out variables. So we have three options for those: input, output, and in-out. Now, in-out is what you would use if you had to bring in an array of data, or if you wanted to bring in a structure. Those would be in-outs. For what we'll be doing today, we're going to be either input or output. And finally, the externals category. This is a variable that references an outside world variable. So if there was a global e-stop flag somewhere in your facility, you had access to it, you could actually read that directly without having to map it to your function block. Now, I'll get everyone to first create their variables, and I'll go to the next slide here. So our variables are all going to be in-out variables. We've got 4 inputs and 2 outputs. And I'm just going to leave this up on the screen, and you guys can recreate this on your own function block. If you're having any issues, now's a good time to speak out or type it in chat. Once you guys have created the variable names, you can recreate the logic listed below. Norman, how you doing? Window. Okay, does anyone need some more time with that one? Okay, so what I'll get everyone to do now is replace the motor. Actually, this won't work in our program, but we can just add this into our analog section just to see it in action. So if we go to analog program, the very first program where we have our scale transformation, and just drop one down on a rung by itself, we can go to ladder tools, function block, and the name of the function block is motor control. Because it's a function block, it needs a name itself. And now all of the inputs and outputs are what we defined as inputs and outputs in our custom function block. So if we just want to see this in action, we can put some test variables there. And they can be internals, it doesn't matter. Now we'll get everyone to fire up their simulator and play around with their new custom function block. We're not going to run it with the HMI simulator for this. We just need the controller simulator. And if you recall from the first day, when we're in our simulator and we want to flip a bit, we can just double click on it. And there will be a little window that pops up saying true or false. Is anyone having any issues with that? You guys are good. All right. We can go ahead and stop our simulator now. Did anybody have any questions on the function block creation or implementation?
Please show the motor control one more time. The
The
function block,
function block itself or the code inside?
the code inside the motor control.
Yeah.
it's good. Thank you.
Okay, now in Sysmax Studio, we have something called a library. Now, Omron provides a number of these libraries for use with our products, and these libraries consist of PLC code, usually function blocks, and HMI objects that go with them. So these are free of charge, and they are supported by us, but you can also make your own libraries and IAGs. This is comparable to, say, an add-on profile. Now, what we're going to be doing in this exercise is importing the training library, and we're going to add it to our project. So with the, let me just open up the student material here. So the folder that was distributed ahead of time, for session 3, there's a training library.slr. So that's what we're going to be grabbing. So as long as you know where that is, that's all that matters. In Sysmac, we're going to go up to Project, Library, Show References. And mine's actually already in here. I'll just delete it. So we're going to hit the plus sign at the bottom of this window. And that'll get everyone to navigate to that student material folder, session 3, and click on training library.slr. We'll hit open. It's going to warn you about instruction versions. Just hit OK. That happens every time. And then should now be listed in your library references. And you can go ahead and click OK. Did that work for everyone? Okay, now you may have noticed on the right-hand side, up at the top, there's now a new category in your toolbox. It's called Training Library. And if we expand that, there's a function block in there called Analog Sim. So what we're going to be doing with that function block is replacing this int to real instruction that's located in the analog section of our lift station logic. So you can just delete the int to real function, and we can drop the analog sim on the rung before our scale transformation block. And all we have to do here is just put tank level real on the output. Name the function block. And then we don't have to put anything on sim min and sim max. The defaults are 0 to 8,000 that it will simulate between, and that's what our scale transformation is set for. So I'll give everyone a second to do that. And once you're finished, you can fire up your simulator. And this will simulate the changing tank level in your lift station. If you're having any issues, type it in chat or speak out.
Hey, Stu, I missed this part where to import that file.
Okay, so go to Project, and mine's chugging along here, but Project, Library, Show References.
Okay.
Yeah, and then just click on the plus sign in the window that pops up and navigate to the student material session 3 folder, and there should be a training library in there.
Okay, perfect.
Yeah, so what this function block does from this library is it just simply ramps between 0 to 8,000 at a seemingly random pace. But you can make your own libraries. If you had a function block that you would always use for your analog inputs with built-in alarms, for example, you can make a library, maintain that library, and that library can be a part of all of your future projects. And it's a very easy, convenient way to reuse your code. Now, if we ever want to get inside a function block or a function that we created, by right-clicking on it, on the instance of it, we can select Go to Lower Layer, and that opens up the instance of that function block, not the base instance, but that specific instance. So we can look inside of a specific instance of a function block instead of just looking through the base function block. Now, if we wanted to edit that function block, we could open up the base unit for it. So I'll go to the motor control here. And we can perform an online edit to the base function block. I'm going to just say, add my motor failed to start as a condition to run. And now when I send those changes as an online edit, every single instance of that function block is running the new code on the next scan cycle. Is anybody having any issues with that?
So you just got rid of the integer to real conversion and put that simulator in?
Yep. Yep. So now when we're testing our lift station, we don't have to keep entering new values in our raw value that's tied to the analog input card.
I see.
It'll just start changing the level for us and we can test our logic that way.
I got a quick question. So I actually wrote a simulation program just in some structured text to make the level go up and down, but it's in its own program. Are you able to enable and disable separate programs within your code?
Yes. So
How would I do
it's its
that?
own program or its own section?
Its own section in the program, yeah.
Okay, so if it was its own program, we could remove it from our tasks, but being its own section, if I wanted to disable this logic section, I can, give me a second here. There is a way to, the easiest way would be to just add a new ladder program.
Yeah, and then take it out of the task.
And then you can drop it into the new ladder program.
Yeah.
And this new program doesn't have a task assigned to it, so it's not going to run any of the logic in this new program.
Okay.
So how could we make our own library of a function block?
Yeah, good question. So when we start up Sysmax Studio, I'm just loading one up here for you. When we go to create a new project, we have a couple different options. Just give it a sec to load here. So we have standard project. That's what we've been working on so far. My computer's a little bogged down here, sorry. And then we have library project and IAG project. So IAG project is basically a library for the HMI. Library project is a library project for your PLC. So you would create a library project and everything that you add to it here. Let's make that. So every function and function block that you create in your library project becomes part of that library. You could have a bunch of different function blocks. You could have a bunch of different functions. And then when it comes time to actually use this in your project, you will go to library, create library. And it will go through the build process. And now it's going to save it in that SLR format that we saw the training library come in as. So you can see here, testlib.slr. So this would be my library file now that I publish. And then any changes I make to it, you know, I can come in and make whatever changes I want and then publish that again to that library. Now, this training library I just made ahead of time for the library importing example.
Thank you, Stuart.
Sorry, what was that? Your mic's a little quiet.
Thank you. I appreciate if you could send that the document with the rest of documents that you usually send. How to create the library. So you said you have one. So it would be great if you could send that over.
Well, yeah, so the training library is included with it. I don't think a document on how to create libraries is, but yeah, the base project, you know what, I'll send out the base project that I made to actually create this training library if you want. And then you can open up that library project and, you know, just kind of connect the dots.
Thanks.
Okay, anyone else have any questions on libraries and how we work with them? Okay, so now today's main event. We have a situation. Engineering made a mistake when converting from the inferior imperial system, and they undersized the lift station. So we are going to create a function block for the lift station, and it's going to contain all of the code from the current lift station, and all we're doing is just duplicating our lift station. So it's going to be easier to make a function block and make another instance of it, because we might need to add to this lift station down the road, and that'll save us some time. So we'll create another program for our second lift station, and we're going to duplicate all our tags, and we're going to add an underscore ls2 suffix to them, lift station 2 suffix. And then we are going to add the function block to our program and assign all of our new tags with the new suffix. So I don't expect you guys to know how to do all of this. I'm going to be playing along with you here. So when we want to convert a program into a function block, we go to that logic, wherever it is in our PLC, and we select all of the logic that we want to take out. So I'm just going to go to the logic section. I'm not going to bother with the analog stuff in the simulator, just the logic. And I'm going to click on rung 0 and go all the way down to the last rung and just shift click to highlight them all. And I'm going to right click and choose copy with dependence. Now I'm going to add a new function block, ladder. And I'm just going to call this lift station FB.
What will happen if I take copy only without a copy with dependence?
Copy versus copy with dependence.
Yes, if I select only copy only without copy with dependence, what will happen?
So it's more for when you're taking it out of one program to another. It just brings all of the variables with it. Since we're staying within the same project, I think we could get away with copy. When you use copy with dependence, it pulls all of the links and the global variables and any custom function blocks that you might have in the logic. So in our case, copy would probably work, but in the future, if you had some function blocks in here, you had some structures in here, you would want to use copy with dependence. So we're Due to the size of this, copy would probably work, but it's good practice to use copy with dependents when you're doing something like this. But now we can go into our list station function block. We can right click in our new function block logic, and we can choose paste. And you can just delete the blank rung in there. Now up at the top of your logic, there's the variables drop down. So zoom in a bit here. So if we click on the variables drop down, all of the variables that we pasted into here were pasted as externals. So since we're going to be reusing this with unique variables, we don't want those to be externals. We want them to be in-out variables. So I'll get everyone to, once again, copy all of the variables in externals, or sorry, highlight all of the variables in externals, right click on them and choose move to internals. And when it prompts you, you can delete global variables. You want to choose no. And now from internals, you can see all of our variables got moved to internals. And we can select everything except that T700 FTS or the on delay timer data type. Select everything but that. And we're going to move them to in out. So you can't go from global to in out. You have to go from, well, external to internal to in out. So there's a bit of an extra hop in there, but now we have all of our variables as in out variables. So what we're going to do now is assign everything you see on the left-hand side of this function block will become an input. Everything on the right-hand side will become an output. And I'll be playing along with you on my copy here. Sorry, I was hoping I could zoom in there, but has everyone changed the in-out type to match what I have here, or do you need a little more time?
Just another 30 seconds.
Yeah, no worries. I'll leave this up. In run mode should be an output due to the very first one there. So we've now taken all of our lift station logic and we've converted it into a function block. So if you have to write the same code more than once, it's definitely the way to go.
Good to go?
Okay. So now we're going to make another program for our second lift station. We'll go to Programs, Add, a ladder program. And I actually already have one in there, so we're going to rename it Lift Station 2. And the section here, section 0, we're going to call this LS2 logic, or whatever name you'd like. It just has to be unique. And now because we created a second program to run, we have to go into our task settings up here. And we have to add that program to our task. So on the program assignment settings in task settings, so far lift station 1 is in there. It's in there by default. If we click on the plus sign, we can assign lift station 2 to our primary task as well. So it will run at every scan, just like our first lift station will. And if we ever got so many lift stations on this plant that we were tripping the watchdog timer, we could go into periodic tasks instead of our primary task, and we could have things run at different intervals, but that's kind of a lesson for another day. So was everyone able to add their second program to their primary task?
Can you show how you add the lift station 2 again?
Yeah, so right click under POUs, we have programs, and you can choose add, right click on programs, choose add, and then pick ladder.
Okay.
And then that will make a program 1 section 0, and then you just rename those lift station 2 and lift station 2 logic. And then once that's been created, you can go into your task settings, and that should appear when you add a program to the primary task. Give you an extra minute to do that.
Sorry, if I don't add to the task, the program will not look at this function. It means will not add this lift station 2 will not look at it, or the execution, during the execution it will not take station 2 into its consideration to execute.
Correct. Yeah, the logic will be there, the code will be there, but it will not be executed.
Oh, you mean that when, say, for example, when I start a new structure or something like that, can I work offline like that? And after I complete it and test it and everything okay, can I add to the task to put it inside the execution cycle?
Yes, you could when it's ready to go.
Yes.
Yep, and there's also another thing we can do when we're simulating. We can actually exclude it from the simulator when we're running our simulator. But yeah, that scenario would work. So we've made our lift station function block that has the identical logic to our first lift station inside of it. And we've made a program for it. So now I'll get everyone to go to their ladder tools, drop a function block on the first rung. And the name of the function block is going to be our lift station function block. And we'll give it a name. Now, before we start tagging things, let's wait till everyone's caught up here. Before we start creating all these tags, we already have these tags for lift station 1. So there's got to be an easier way than typing them all from scratch all over again. So what we'll do for that is we'll go into our global variables. And you guys can go ahead and delete any test variables that you had as a global variable. You can go ahead and delete the offset examples, or just don't select them, either one. If you want to keep them there for the future reference, that's fine. But we want to highlight all of the tags that are pertinent to lift station 1. And we want to choose copy and click down below and choose paste. There we go. So now it's going to paste everything with an underscore copy suffix on it. Sometimes it's picky about where you click. So you have to click to the left of the tag. You can't click on the tag name. It has to be on the left-hand side of the tag name in that little box there. Did that work for everyone?
Sorry, why I'm doing this?
Well, we've duplicated our logic, but we
Or-
need to have unique tags for the function block that we just created. We need to have unique tags for our second lift station.
Oh, yes. Yes, okay.
If we put the same tags as our first lift station, then we're just going to kind of execute the logic twice. So in our global variables, I'll get everyone to go to their global variables. And then I'll get you to go to edit, search and replace. I'll make this side a little bigger for you here. So we're going to change this to look in the current view, which is global variables. We're going to be looking at the variable name. And now we're going to be searching for underscore copy, and we're going to replace it with underscore ls2. So we want current view, variable name, and default as our options. We're looking for underscore copy, and we're going to replace it with underscore ls2. And then once you've filled that out, you can click on replace all, choose yes. And now all of those tags that had underscore copy on them have underscore ls2 on them.
Could we use a structure to have 2 instances for each station?
Absolutely. The reason we didn't go that route is we would have had to essentially retag all of our logic with the structure variable name instead of this variable name. But that's absolutely something you could do, and you could have one structure for your entire plant if you wanted to. So is everyone able to rename all of their underscore copy tags to underscore ls2? Anybody having any issues with that?
Can you show task setting one more time?
The at setting?
Yeah, task setting. Yeah, because I couldn't generate. Yeah, here, where I can find this task setting.
Yeah, so in the Multi-View Explorer,
Okay. Okay, I
fourth
got it.
fourth item from the bottom, and then once you're in here, you'll go to program assignment settings, and then just click on the plus sign.
Oh, okay, okay.
Then you can drop lift station 2 there.
And what's the reason we have to do that? If I keep using the station 1, not creating the station 2, what will be happen?
You could have. So there's no limitation in how many sections you can create. That was more just an exercise in creating a new program and assigning it to a task. You could have the LS2 logic in the lift station 1 program. There's no reason that we had to have it on its own. That was just an exercise in assigning a program to a task.
Oh, okay, okay. Got it. Thank you.
Yep. Okay, now in our global variables, everything that we tagged _LS2, some of the items retained an @ setting here in the @ column. Just delete those because they're not going to be assigned to those inputs. So just go ahead and delete those. Now back at our LS2 logic, our lift station 2 function block here, everyone can go ahead and tag their function block with the LS2 tags that we just created. And you'll want to pick all of the LS2 tags for it. Give everyone a minute to finish that part. Does anybody need a little more time or have any issues? Okay, so now that that's all tagged, the next logical step, we're not going to do it just in light of time, but we would need to map our inputs to our IO map or create buttons on our HMI in the case of the HMI tags. But we're going to skip that step in light of time, but that would be the next step. So obviously creating list station 2, list station 3, etc. would be much quicker than copying and pasting all your code and changing the variable names over and over again. Now, like somebody mentioned, we could actually make a structure for this function block with all of these tags on it. The only downside there is we can't assign a structure member to our IO map. So just elementary data types on our IO map. So you would have a bit of mapping surrounding your function block, but you could easily do it with a structure, and that still probably would save you time. Okay, any questions before we move on? We're doing all right for time here. Okay, so mass tag manipulation using Excel. So I'm sure a lot of you have done this when you're transferring variables to and from an HMI or a PLC or some of your project documentation. So if we go into the student materials folder here, there's a folder called tag exercise in session 3. Get rid of the copy here. So I'll get everyone to open up device list. And that should bring up, this is unrelated to the lift station, by the way. This is just an exercise in how we accomplish this. So that opens up an Excel spreadsheet with a device list on it and a location comment, as well as range and units. So we often get project documentation like this, either spreadsheets about, shutdown set points or functional descriptions, that sort of thing. Now, we need to create all of these tags in our PLC. But if we tried to cut and paste from Excel, it wouldn't know what to do with most of these columns here. So what we can do, and you guys are more than welcome to play along here, is if we go to our global variables, and let's just grab any reel with a comment. I'm just going to make a comment on this one. So grab a reel with a comment. If you need to make one, go ahead. And then we're going to right click to the left of the tag name, and we're going to choose copy. Then we're going to bring that into Excel. And on a row or two below the last line there, I'll get everyone to just paste that into Excel. So this is the format that we just pasted that Sysmax Studio is expecting. So now we can essentially format all of our data from an Excel spreadsheet and make it the same format that we need for Sysmax Studio. I'm sure a lot of you have done something similar when you're bringing tags over to a third-party HMI. It's a very similar exercise. I'll give everyone a second to do that in Excel. Anybody need more time?
Maybe just another 30 seconds here.
If anyone was curious how I occupied all of the sect rows in this column with real or false, that sort of thing. If you click on something in Excel and you grab the bottom right corner and drag it, it will fill according to what you have selected. So that's all I did there. And once we've got our list of tags formatted for Sysmac, I'll get everyone to click on the top left tag and then shift click on the very bottom right-hand comment. Choose copy. And then we can go back into Sysmac, into our global variables. And we can choose paste. And you can see it's brought all of the tags from that Excel spreadsheet into our project with the comments that we specified in the Excel spreadsheet. Did that work for everybody? Okay, now the final exercise for the day. This is exactly what we just did there. Is called bit interrogation or bit extraction. So essentially picking out a bit within a word of data. So this is very common when you're doing things like Modbus. You get a word of data back and you need to look at a very specific bit within that word of data. Now, in some platforms, you can type the variable name and then a period and then the bit number, and that will allow you to access the bit. But in Sysmac, we don't have that capability. So there's a few different ways we can get bits out of a word data or out of an integer. In our variables, there's an AT column. You guys should be pretty familiar with that now. So what we can do is we can assign an address to the AT column. Now we still support addresses just for backwards compatibility with some of our communication protocols. So we have our AT column here, and this is where we will specify the address. So the first thing we need to do is turn on the address support. So in our Multi-View Explorer, we can go to Controller Setup and then Memory Settings. And then I'll get everyone to check off the DM. And that will allow us to use D registers in our global variables. Now the syntax for doing that, I'll get everyone to make two new variables. One of them will be a status from VFD, and we'll make this a Word data type. And I'll get everyone to make another variable, call it VFD bits. And we can use that structure that we created earlier, VFD control user. And in the at column here, normally we want to avoid overlapping or duplicate addresses. But when we assign the same address to something in Sysmac, the contents will be mirrored between variables. So the syntax we need is %d and then an address. I'll just start with 0. And we're going to assign that to both of them, %d0. And because we're using D registers, we do have to check off retained. That's why it's pink. So we have a status from VFD, that's a word, and we have VFD bits, which is our structure that we created. Usually, let's say over Modbus, for example, we're going to get that data back in a word. And because we're sharing this address, the structure that we made is going to have all of those bits going to the correct location. So once you've created those variables, I'll get everyone to run their simulator. I've got an error in my program somewhere here. Is. So everyone can go ahead and run their simulator. And if it asks you to rebuild your controller, if you go up to Project Rebuild Controller, that will take care of that. Okay, once your simulator is up and running, get everyone to go to View, Watch Tab Page, and View, Watch Tab Page with table in brackets. Now for the Watch Tab table, this is what we use to look at structures and arrays. So we'll put the name of that tag that we created, the structure that we created, which is VFD bits in my case. And then in the watch tab, the regular watch tab, I'll get everyone to put the status from VFD, the word. So in our scenario here, we're getting this status word from the VFD, and we're mapping it through an address to that structure that we created. So you can put a value in the modified column, just pick a number. This is a hexadecimal value here. But when you change that number, when you look at the structure itself, that binary pattern of that value that you put in will be reflected in these bits. So there's no logic linking these. There's just that address that we specified in our global variables. So this is the most clean and efficient way to extract bits from a numeric data type. And this is very helpful when you're doing communications. There are some instructions that we could use to map these two directly together. This way, it just kind of does it behind the scenes. So did that work for everyone? Are you able to recreate that?
So I have a question. Assigning the same address to two different variables doesn't create some sort of conflict or some it's a bit confusing. I know what you're doing, basically mapping to the structure by assigning the same address, but because we are reading and writing to the same address memory, that then create some issues, or
Yeah, I understand where you're coming from for sure. And it works both ways. So if I'm in my watch table and I go around and I flip some bits here, it's going to change the value. Oops, did I not make them true? I have to make them false. Okay, so if I were to flip some bits in my structure, it's going to actually change the numeric value of that. So as long as you're only writing to one of them, then the other one will always retain that value. So that's the main thing you have to be careful of. It will allow it, and it's just going to copy the contents of D0 to both of them. So as long as you're only writing to one and not the other, then you shouldn't have any conflicts. If you were trying to write to both of them, then whatever the last executed operation was is going to take over. So if you wrote to VFD bits after you wrote to status from VFD, then VFD bits would be the value that's stuck. So that's really the only potential for conflict. So since we're just monitoring these VFD bits, they're just statuses. We're just reading from them. We're not writing to them, but it will allow it. And the contents, I'm not sure where in the scan cycle the contents get mapped to each other, but did that answer your question?
yeah, definitely. Yeah, thank you.
Hey Stu, I'm getting an error that says the area does not exist in the memory used for CJ series.
Yeah, so go to your Multi-View Explorer and under Configurations and Setup, go to Controller Setup, expand that, and then go to Memory Settings. And then you're going to want to check off DM. And that will enable that memory area for CJ.
There we go. Thank you.
And then it'll probably ask you to make it retained as well, because that's the memory in our older controllers is retained memory. So it's just kind of a backwards compatibility thing. Did you get the watch tabs both open there?
Just doing that right now.
Okay. Yeah, you want both watch tabs. Now, if you didn't have a structure here, this VFD control user data type that we created, if you just wanted to pick the bits out, you didn't want to get so involved as to make a structure, this could be a Boolean array with 16 positions, a bool in brackets 16 Boolean array, and that will work the same. The first bit of word is going to be the first bit of that Boolean array, position 0, index 0. The most significant bit will be index 15. So we don't need to make a structure if we just want to pick a bit out of a word quick, use it for something, and then be on our way. We don't have to go through that whole structure process. I can do that as an example here too. Now, if I make it all ones, and I look at the contents of that Boolean array, that's how it looks. I've got 16 Boolean values that are reflecting that word of data. And same thing when I flip bits in here, it's going to be reflected based on the last operation that I performed. Now, if you don't like working in hex, the word data type always displays as hex, but we can change the display format to decimal or Boolean. Decimal might make more sense to some. If this status from the VFD was an unsigned integer, for example, it would automatically be displayed as a decimal value. It wouldn't be a base 16 value. So, is anybody having any questions or issues? We've got a few minutes left here.
So I got the global variable corresponding to the external variable has not been registered, but I think I already registered, so I don't know what's going on. Yeah.
So
Do I need to re-register again?
So go to your when you go to project, check all programs.
Okay.
Okay, then go to your build tab here. Down at the bottom, it should be there automatically.
Yep.
Errors are shown in red.
Yep.
And when you double click on that error, it should bring you to what is causing that problem.
Yeah. It got me to layer, but it's under the lift station 1 and external variable.
So up here on the, like at the top of your program, there's a variable that's in red.
Yes.
Which variable is it?
All of that. Yeah.
Oh, did you might have clicked yes when it prompted you to delete them all?
Oh, yeah. So I should do, so how, if I want to, how can I do one more time? How can I go back? Do I need to, yeah.
It's a good question. I've never had to go back that far. You could try edit undo a couple times to see if you can get that far back. But that's been a ways back.
Oh, that's okay. I can redo one more time. Yeah.
And I will be distributing this program at the end of the class too. So you're not kind of stuck here at that step too. But yeah, I think when we copied and pasted all of those variables into our function block and then moved them to internal, there was a little text box that popped up saying, do you want to delete all references to it? And I think you clicked yes instead of no.
Okay. Yeah, I think so. Yeah, so I need to select no, not the yes. Okay, I got it. Yeah.
I think how we could load that. Yeah, I mean, I know one at a time you could right click on them and choose register and variable table, but that's a bit of a pain. You could try just deleting all of the ones that are in red.
Yep.
And then rebuilding your project.
Okay, I see. So how about if I do one more time about copy the dependent one more time and paste, but this time I select no, not delete all of the variable.
Yeah, you'll have to, it'll be when you transfer them to the internals that it'll prompt you for that. And yeah, you just click no.
Sure.
Okay, well, we are out of time today, guys. Thank you for those of you who attended. I'm going to stay on for a few minutes after here if anybody's having any issues. So if you got some stuff to do, thanks for showing up. And if you want to hang around after and look at some stuff, we can.
This lecture will be recorded and you will send to us the video of this lecture, yes?
Yep, same as the other sessions, the video, the PowerPoint, and the program, the completed program will all get distributed.
Yes, perfect. Thank you so much.